and we'll discuss about the other keywords, that is throws, and finally. And we are going to even with an example see how we can make use of user-defined exception class and even with the chained exceptions too. Fine. So now we will see how the throws keyword will be used, the fourth keyword of your exception handling in your Java program. So an exception which a method or procedure cannot handle. Fine. So as you have seen now, I've just shown you a method can have a try clause and a catch clause. So now there are few exceptions which the method cannot handle. When a method is not able to handle an exception, by default it is going to pass on that exception to the calling method. A method has been called by calling method. If this called method is not able to handle the exception, that particular exception should be handled by the called method, hence the called method will pass on the exception to the calling method. When this happens, the calling method should be ready. It should be ready to handle the exception what the called method is going to pass on. It should be ready. If it is not ready to handle such exception, it is going to end with a system break or it's going to end with a syntax error. Hence, the caller of the method should guard themselves against such exception. Can it handle the exception? Then it's fine. If it cannot handle the exception which the calling method cannot handle, then it's going to be a severe problem. Hence, you need to make sure whenever a method is going to pass on the exceptions, the calling method should be able to handle this. Hence, using throws keyword, I'm going to list the type of exception what the method is going to throw. Hence, your calling method will be ready, will be prepared to handle those list of exceptions what it can expect as pass on exception from the called method. This is where I'm going to use the throws keyword. Now just look at this example how it's going to work. But before that, so just listen, method should list such exception which it may pass on as I just explained to you. And so now the exceptions which belongs to the error subclass or the runtime exception subclass or the subclass of these two subclasses need not be mentioned, because your calling method will be always ready even though you list it or you're not going to list it in the method what you design. So your calling method will be ready to handle all these errors. But there are few more errors which it cannot handle. Hence we call this as checked exceptions. The exceptions which cannot be handled by default by the calling method, we call this as checked exception. And the list of exception, that is the exception of this classes or the subclass of this classes, can be handled by the calling method, and we call this as unchecked exceptions. Fine. If it is unchecked exceptions, you need not list. You need not list such exceptions. The calling method by default it can handle. Hence it can guard by themselves. But if it is a checked exception, if you don't list it, you need to list it. If you don't list the exception which the called method will pass on, and if it is a checked exception, and if you don't list it, it will result in a compile time error and Java will not allow you to execute the program. Hence, if your method is passing on the checked exception, you need not list it out in the method declaration. If your method is going to pass on the checked exception, then you need to list such exception in the declaration of your function. So remember this. And so now whenever we are going to have such scenarios, now this is the syntax what I am going to have. That is, I am going to have the return type, the method name, the parameter list, the same what I do with the function declaration. So along with this, I need to have the throws keyword. I'm going to have throws keyword in the function header and the exception list. I need to list out the exception what this function is going to throw, and specifically list the exception which is going to be the checked exception. In few minutes I will tell you what are the list of checked exception and what are the list of unchecked exception, and as usual I'm going to have the body of the procedure. And so now when I'm going to use this, either I can put it one exception if the body is throwing. If it has got more than one exception, you can do by using comma separator. The exception 1 comma, exception 2 comma. I can put the list of exception which the method can throw. So fine, and this is how the general form we are going to use. Now just look at an example of that. I am just going to have class throw demo. I am going to have a procedure and I am going to have main function which calls the procedure. Now main function becomes the called procedure and the procedure becomes the calling procedure. And so now this procedure is going to throw and creates an error or creates an exception, and it's going to throw the exception. You can just observe illegal access exception. This exception is a checked exception. Hence, the called method cannot handle by default. Hence, now this method is not going to have any catch clause which it can handle. When it cannot handle an exception by itself, the exception will be passed on to the called method or the called procedure. Now in this called method, there is no catch clause or it's not prepared to handle the exception. Hence, when I compile this program, for sure I'm going to get syntax error because the method is passing on an checked exception and you're not listed that. If you don't list it, you're going to get a syntax error. If in other case, if it was an unchecked exception, something like arithmetic exception, if I created an arithmetic exception and if I have executed this program even without listing it out, so the default handler would have been come into picture and it have been executed and it would have been not a syntax error. But right now your method is passing on an checked exception. You need to compulsorily strictly list that as the exception what the method is going to return. Hence for this program to be synthetic error free, we are going to make two corrections. The two corrections are required. The first correction is I need to list it. The second correction is when I list it, when I pass it, this procedure or this main function which is a called function should be capable of handling the error. The two corrections I need to bring in. Hence the first correction what I'm going to have is I'm going to list it out. So with the function definition or function declaration, I'm going to use the keyword throws, and the type of exception what it is trying to throw is illegal access exception. So now I have been listed it out. Hence now there should not be any syntax error at this point. The second correction is I am bringing this function call inside the try block. Hence once this method is going to pass on this exception, this try block will throw this to the catch clause, and now this catch clause can handle this error. Hence when I execute this program, I am going to print this message first. I am going to print this as I am procedure and I am going to throw illegal exception. I am just throwing this exception. Nothing is printed here. This is a message what I am giving by using the constructor with one parameter of this class. And once I am going to be in this try block, this will throw the except to the catch clause, and I am going to print I can handle you as the string what I want to print plus E. E is going to be of the type illegal access exception, and in this I have printed the message as you can't handle me. Hence I am going to get the output as I can handle you, and the description of this error, that is java lang dot illegal exception, and the message what I have been saved or what have been initialized using a parameterized constructor as you can't handle me. Now this is how the throws is going to work. So in similar way with the throws keyword, if the method is passing on multiple exception, if this method is going to generate multiple exception, and if it is an checked exception, all those exception to be listed using separated by comma operator. And now this is how the throws is going to work. Now we'll just see how the finally keyword is going to work. So when exceptions are thrown, execution flow is halted. That is, immediately the try block halts the execution and the exception is thrown to the catch clause. Now the catch clause is going to execute the remaining statements. Hence, the try block remaining statements, what it was to be happened after the exception statement will be skipped out. So for example, if all those statements are not so important statements, then you can skip it out. But if the statement was supposed to be executed, even the exception has been occurred, before I'm going to terminate my program, abnormally or normally, I need to make sure some set of statement is to be executed. Even the exception occurs, the set of statements should be executed. Even if the exception doesn't occur, the set of statements should be executed. Fine, if such statement is to be executed, I need to create block of such statement, the statements which must and should be executed on any case. If an exception occurs, this should be executed. If the exception doesn't occur, this should be executed. If the exception is handled by a catch clause, this block should be executed. If the exception is not handled and handled by the default handler, still this block of code should be executed. If any such statement which compulsorily should be executed, make sure you create block of code, block of dot code that will be executed even after try or catch block is executed or both. Hence, that block of code we need to put in the final block. Hence, we'll execute whether or not exception is thrown. We'll execute even if no catch statement matches the exception. Finally, clause executed will return even from method. Even if you are returning from the method due to exception or due to no exception, the final clause will be executed if you are putting a final clause inside a method. And that is how the final clause will be used. And the final clause is optional. If you want, you can use. If you want, you can just keep it away. But using final clause is a better way. Whenever you use a try statement, it's a good programming practice. If you have at least one catch for the try statement or one final clause for the try statement or both, it's a good programming practice. When you're going to have a try statement, either you associate with a catch and associate with a final clause. And remember, when I use a try statement, when I use a catch clause, it should be followed immediately. The catch clause should be followed the try statement immediately. But that's not the case in the final. You can have the final clause block anywhere in your method or anywhere in your program, irrespective of where the try statement is going to be. Remember this. Hence, now we will just see an example how exactly we are going to use the final keyword. Now just look at this program. So class finally demo, and I'm going to have static void procedure A. I'm going to have a procedure A. I'm going to have procedure B. I'm going to have procedure C. I've got 3 procedures or 3 functions, and I'm going to have a main function. Inside this procedure, I'm going to have a try block. I'm going to have finally block. There is no catch block or the catch clause for this. And even for this, I'm going to have try and finally. And even in this case, I'm going to have try and finally. Now, what difference this 3 makes is, now when I call this procedure has been returned to its calling procedure, due to exception occurrence. I've created an exception and the counter will immediately return. And now in this procedure, observe the control will not return due to an exception, but due to execution of a return statement. Immediately the control will return to the call statement. And in this case, there is no exception and even there is no return time, and by default when I reach end of the function, it is going to return. Now in any of this case, whether I am returning from a procedure due to an exception, the finally will be executed. If I am returning from a function due to execution of a return statement, the finally is executed. Even if I am not having any exception and even if there is no return statement, by default I have reached end of function. If I am returning, the final is executed. Hence the finally block will be executed on any given case. That is what we are going to have the output. When I call the procedure inside the try block, so now this is going to return a runtime exception. Now I need not specify this as a list because this is an unchecked exception. I need not list in the procedure. I am going to get the output as I am A and the exception has been thrown. So before the control will shift to this catch clause, which is going to catch the exception, the finally is executed as I am a final. Before I return, the finally block should be executed. Then I'm going to control shift the catch clause and I'm going to print the statement as I am exception. And next the control will come to procedure B method call and I'm going to execute I am B and I'm going to execute return. But before returning, the final block will be executed. And I will read the calling method and again I'm going to call the procedure C. I'm going to enter the try block and I'm going to print this as I am C, and before I return I'm going to execute the finally block also as I am C final. Now this is how the finally keyword will be used with this example. Fine. So now with this, when I was talking about throws, I just told you when I'm going to use the throws keyword, you need to make sure your method is going to list out the checked exception and it need not list out unchecked exception. Now whatever the list of exception I have been put over here, I am not going to describe what this exception does. Few exception you already experienced how it's going to work, but one by one I am not going to do. If you want more information of this, you can browse or you can reach me out later. But now these are the list of exception which we call this as the unchecked exceptions, which you need not list from the method declaration using throws keyword. But these are all the checked exceptions. Hence, whatever the illegal access exception I used, this was a syntax error for me because it was a checked exception. If your method is throwing any one or any of this exception, you need to make sure this has been listed in your function declaration using the throws keyword. This is what you should do. Even you can list out the unchecked also, but it is optional, but it is compulsory to list these exceptions. Now with this, we can create our own exception subclasses. Until now, whatever the object or whatever the instance we have used of exception, this was all the classes which already exist in the class hierarchy of exception. But now we will just see how we are going to create an subclass of our own. And whenever you're going to create a subclass of your own exception, the subclass should be the subclass of exception class only. Remember this. Whenever you create your own subclass of exception, it should be the subclass of exception only, which in turn inherits the throwable class or throwable property. And now that is what I'm creating a class here. I'm creating my own exception as my exception name, which extends the exception class. And now this becomes the superclass and this becomes a subclass. Now inside this class, I am going to store a value and I'm going to have my exception. Using this value, I'm going to using this constructor or parameterized constructor, I'm going to initialize the value for this data member. And I'm going to have one public member or then inbuilt member function, what we call as toString, which will convert or which will return the string what I'm going to pass. That is, now I should return a string called as my message plus whatever the value I'm going to initialize. This will just whatever the string I'm going to get, it is going to return as a string to my program, and this is an inbuilt method name, or I'm going to override this method, which is the method of a throwable class. I'm just overriding this method to create my own message or to create my own format of message. And so now when I'm going to create my class, I'm just going to have a method called as void compute, and I'm going to say throws my exception. Now whatever the exception you created, this is a checked exception. This should be listed out. Remember this, whatever the exception you create, it is going to be an checked exception, and this should be listed out using the throws keyword. And now this method checks the value what I'm passing. If it is greater than 2, then it is going to throw the exception. What exception I have been created, it is going to now create the instance of my own exception now. Remember this. Now this is my own exception, which the instance I'm creating or exception I'm creating by passing one parameter for this parameterized constructor. And I'm going to print this message, and from the main function I'll be calling this procedure. Hence I'm just going to call this procedure, and this try block has got one catch clause which can catch my own exception and print a message. Now when I execute this program, and when I call the main function, I'm going to call a procedure or a method called as compute1. Hence I'm passing 1 as a parameter for ye. Now this was supposed to be capital C. Please make a correction. And I'm just going to pass value 1 for this ye, and I'm just going to throw an exception. When this condition becomes true, now the value of ye is 1, now 1 is greater than 2, condition is false. So now this statement is not executed. Hence I'm going to print the output as no exception and return from the function, and just execute the next function call by passing the value 5. Now 5 is greater than 2, the condition is true, throw new exception, create the exception of my type by passing the value of a as 5, and now the constructor will be called and the value is going to be 5, and I'm just going to return from this function, and there is an exception which has been thrown from this method compute. The try will throw that exception to the catch clause, and the catch clause is going to handle the exception, saying system.out.println caught plus e. I'm going to print this message when I'm trying to print something. This is an inbuilt method, defined method. This will be called whenever I'm going to call the println function. Whenever you're going to call a println function and the object of the class, so this toString function will be called by default automatically, and this is going to call this method, which I'm going to print my message with the value. Hence the caught is printed, my message, and the value what I'm going to attach is the value 5. And this is how you can create your own exception as a subclass of the exception class. And so now once this is done, so now we'll just discuss about what is a chained exception. So what this chained exception is going to do. So now whenever we are going to have a chained exception, so remember this chained exception what I'm going to have. So a chained exception is where we talk about an exception which has got associated with another exception. So now when an exception occurs, so there can be a reason why this exception has been occurred. That is, now for example, when your program is going to stop its execution, the reason can be anything. The reason can be the input buffer may not work, or the memory system may not work, or any of a external exception can cause this exception to occur. And so now when I'm going to have one exception, there can be associated exception which can stand as an error, and that exception should be identified or should be handled. And if you are thinking about in that case, if an exception occurs, if you just handle, it's fine. That is what we are doing at the first level. Now when an exception occurs, now you can investigate whether there was any reason, any other exception which stands as a reason to make this exception to be current exception, or you can just check it out whether there's an underlying exception or not. That is what the second exception describes, the cause of first exception if it exists. Currently I have a first exception. Whether if there is a cause, can I describe that exception or not? That is what the chained exception is going to be. The top exception has been caused due to the underlying exception, and again this exception can have one more cause, and this chain can go on. That is what we call this as a chained exception. Now for example, there is going to be arithmetic exception because of divided by 0. So that is, now whenever I am going to read a input, I am going to give a value for a variable, and that variable is used for division operation. So if that value is used for the division operation, and if I am giving a parameter input, so I would have not given any 0 as the value for that variable. And now due to error in the input output, I am not able to give a proper input using my system. In that case, the variable by default will be set to 0. And now by default the variable is set to 0 because of the input exception or the input error. That is what the input output error has been occurred. Due to input output error, where I am not able to give a non-zero value for a variable, hence divide by 0 exception has been occurred. Hence the underlying exception is the input output exception. Now this is the cause for the current exception which has been occurred, and so now I need to have a method how exactly I am going to identify. To identify, the throwable class has got its two constructor. One is going to be a constructor to identify whether there is an caused exception, whether there is a second exception which can stand as a cause or not. And if the exception exists, if a cause exception exists, I can even set the message or description about the cause exception. I can use this two constructor, or the throwable class has got these two constructors which I can make use of identifying the cause and the message for the cause. And now whenever I want to check out whether there is any underlying second exception or not, I can make use of the method of a throwable class called as getCause. And so once this cause has been identified, I can initialize this cause with the current cause. I can initialize or associate this cause with the current cause. So now when the getCause is executed, if there is any underlying cause exception, then this method will return the reference of the underlying cause. If there is no any cause exception, if there is no underlying cause, the current exception has been occurred due to its own error. In that case, this method is going to return me null. If there is an underlying exception, it returns the reference of that exception. If there is no underlying exception, it is going to return null. And whenever I am going to use init cause method, I can associate the current exception with the underlying cause exception using init cause method. As now just look at this program example where I am going to have the main function which calls a procedure, and this procedure is going to create a null pointer exception. It is going to create a null pointer exception or the instance of a null pointer exception, and I am going to say e.init cause. I am associating a new exception for this, Hence, I am going to have a null pointer exception. So intentionally, I am attaching or associating a arithmetic exception as a cause exception. So now, whenever there is going to be a null pointer exception, if this null pointer exception is returned to the try or the catch clause, now you have got two exceptions. One is the current exception, that is the null pointer exception, and the associated cause exception under the null pointer exception, which I have done using the init cause method. And the init cause method has been executed for the object of the null pointer exception. Hence, this new arithmetic exception which I have been created, so this is associated with this object. Hence, now this becomes the current exception and this becomes the cause exception. And so now I am going to throw this exception. When I throw this exception, so this try block will hold off this and will throw to this catch clause. So in this catch clause, now the current exception is null pointer exception. Hence this catch clause is matched. This is fine. And if the catch clause was arithmetic exception, this would have been not caught. This would have been not caught because arithmetic exception is the underlying exception, not the outermost or current exception. It would have been not caught. So it is a null pointer exception, which is the current exception. Hence the catch clause is going to hold on this. And I'm going to print system.out.println, and I'm going to print a message, whatever the message E has got. And I'm just going to use the get cause. I'm going to use the get cause, and I'm going to print the arithmetic exception, which is an underlying exception. Hence, when I execute this program, I am just going to get the output as caught, and I am going to print the type of exception, that is the null pointer exception, and the message or the string is current exception, what I am printing. And in this system, I am just checking out whether it has got any underlying exception or not. If I would have not executed this statement, then e.getCause would have been returned me null value. But there is an underlying exception, and this will return the reference of this exception, and the message of this exception is going to be original cause, Java like arithmetic exception, and the cause exception. This is how you can work on the chained exception in your Java exception handling process. Now this is all about in this session. I hope you have understood. Thank you.